Hello, my name is Heinrich Ruser. I'm with the Institute for Applied Physics and Metrology at Bundeswehr University, Munich in Germany. Welcome to this short presentation of my poster describing a new solution for low-cost gestural interaction based on motion estimation of a projected dot pattern. The motivation for our research is to use simple gestures for universal and consistent remote control of different technical devices and appliances in private homes and nursing homes. The main goals are to come up with a remote control which is very easy to use, so no gestures have to be remembered, and low cost, using only a few low-cost commercial components. We avoid using cameras due to complexity and data privacy issues, and designed a lightweight, buttonless handheld device we call Smart Pointer. So what is the basic concept of the Smart Pointer? On the left-hand side, you see the handheld buttonless flashlight-like Smart Pointer being essentially a laser light source, and on top of it a so-called DOE, diffractive optical element, which splits the laser beam into thousands of laser beams, producing a dot pattern which is projected onto the receiving unit near the device to be operated. And a visible light beam is emanated to select the device and switch it on and off. The receiver unit comprises of an array of infrared and visible photodiodes to pick up the projected pattern and the visible light beam and to reconstruct the trajectory of motion and recognize the gesture. The principle of gesture reconstruction is described in more detail in previous last year's IEEE sensor conference proceedings, and can be provided briefly to using the cross-correlation functions of the light intensities at different photodiodes. For the evaluation study, we designed two differently shaped handheld devices we call cross and pipe, and you see the receiver box, the black area being the optical filter to block the daylight, and right to it the electrical board showing the photodiodes in a circled arrangement, and on the edges the LED lights for visible feedback. We then asked the participants to draw gestures with those handheld devices in direction of the receiver box. The challenge then is to find the start and end of the meaningful part of the gesture automatically based on an adaptive rule-based approach. So only those fragments between the two black bars are used for reconstruction and then recognized based on a least square fit of lines and ellipses. On the right-hand side in the table, you see the recognition results for 7 simple gestures. The first one being the pointing gesture to select and the device and switch it on and off. And the others being hand or arm motions up and down, right and left, or circle right and circle left, which can be associated with different functions of different electrical devices in a household. On the right-hand side, you see the recognition results as a true positive rates. So all 131 pointing gestures were correctly recognized, and the remaining gestures were recognized with recognition rates of up to 95%, giving a mean recognition rate of 94%. This promising result encourages us to look for a wider range of different gestures and applications, and to apply machine learning-based algorithms for cluster and neural network-based recognition, which define our next steps of our work. So, thank you very much for your attention, and please feel free to write me and ask questions, give suggestions. Thank you very much for your attention.